Hi everybody, my name's Evan Rose, in case you didn't know me from class, and I am here today basically to present my entire semester project, which is comparing the performance of multiple input devices in three-dimensional environments. And the three-dimensional environments I included here, let me get rid of that, are the shooting experiment. I also have a drawing experiment and then a 3D maneuvering experiment, which they're pretty cool. So I'm just going to jump in here and show you. So right here it says shoot all the targets you see. There are 3 levels, each with increasing difficulty. To shoot left, click your mouse to press right trigger if you're using a gamepad, which says right there, controller. So we're going to start. And right now, it doesn't show down here, it just shows a mouse. I am using the mouse pad. Or not the mouse pad, the trackball mouse, it's very difficult to use, I will say that. But I think it's kind of simple for this experiment. It's just clicking and shooting. And right now for this experiment, what I'm measuring right now is misses, hits, accuracy, and overall time. You can move in here, as can be shown right here, and you can also jump and all that fun jazz and look around and woohoo. It's a pretty simple environment, and to explain that, it's basically that I was learning a lot of things in Unity very quickly. And so when I was doing that, I just didn't really know all the intricacies to it. I was learning a lot of different techniques, such as collision right here, and spawning a bunch of objects and getting rid of them after they collide, and shooting mechanics, and doing ray casting, and just building a simple environment itself, and a lot of randomization between the targets, and having the camera look exactly at the mouse, and the player movement and jumping, and it was just a lot. And then I also had to map that to a gamepad as well, which was an additional hassle, and it just took a lot of time to learn. So honestly, if I were to give an estimate at this experiment versus my other ones, I would say this one probably took me around 40 or 50 hours to figure out, and the other ones took me about 20 and 10 in that order. So it's a learning curve to say the least. And where is this last one? Oh, there it is. It just took me a while. So when I was doing this one, I didn't really know that you could import a lot of assets, and you could just there's a plethora of objects and utilities and tools that you can just import, and I didn't know the half of that. So after this experiment, I watched a few more videos, and kind of understood Unity more, and you'll see in my next experiments they look a lot better. So it was kind of just a learning curve, and also a time crunch at the end when I couldn't really go back in and change all this stuff. But it worked out, so I'm okay with it, and I'm happy with it, and it got good data. And so here's the final screen here, and this basically shows you, as I was saying, your hits, misses, accuracy, and time seconds for each level that was there. So I did okay. It took me a while, but that's how it goes. All right. Oh, and the final thing I'd like to mention about this is the results of it. After I concluded my experiment, I only got 5 people, which I was a bit upset about, but at the end of the day, it's data that still can be processed, and still shows some trends. The reason that happened is I didn't expect I guess expect is the right word, how long this actual experiment was going to take. It took a lot of my participants, just doing this experiment alone, the shooting experiment with each input device, around 30 minutes or so, and it took me only around 10 to do it. So I just assumed it would be about 30 minutes in total to do all the experiments with each 3 input devices, those being the trackball mouse and gamepad, which is a PS4 controller. But it ended up taking participants to do all those experiments with all the input devices around 2 hours or less, depending on the participant. So it was just a big time commitment. I couldn't get a ton of people to finish it. I had around 9 participants' data, but it was just incomplete, so I couldn't really submit it into my paper. So that's a little bit of a bummer, but that's how it goes. Okay, I am going to show you the drawing experiment now, so give me a little sec on that. Hi everybody, I'm back, and this is the 3D drawing experiment, which was a lot of fun to program, and I'll explain that in a bit. Just to get started here, it says if using a mouse or trackball, left click to draw, right click to undo, enter to press enter to advance level, space to jump, WASD movement, or I guess ASWD, lol. And then gamepad, right trigger to draw, left trigger to undo, enter on the keyboard to advance, south button to jump, stick movement to look and move. And for each level and each participant, I use my same computer, which is a Lenovo Legion, just to keep things consistent. Right now, I am using the actual mouse instead of the trackball, which is shown down here. And let's get started. So first level, draw a triangle, square, and a hexagon. And you can do that in 2D space in whatever kind of size you want, and I instructed that. And for each participant, I also instructed if your geometry teacher could not recognize that as a shape, or recognize it as a triangle specifically, or a square as right now, you would have to redo it. And so, as I just did right there, I undid that line. I'm trying it right now. For this experiment, we actually did get significant results by all of our participants. And what was really cool to see is that the drawing was by far the best with the mouse. And I think that kind of makes sense, is because it's just I guess an easier way to kind of spatially map yourself with, a 2D plane into a 3D environment. Whereas, the joystick and trackball, when you're doing curved lines or trying to do straight lines, I guess for the gamepad, it turned out to be really hard, and it took people a long time to get these, maneuvers correct and find out the kind of patterns. And it really accelerates really fast too, which I did on purpose to try to make it a little bit harder for everybody. All right, next level. Draw in 3D a cube and a sphere. And this is by far what took people the longest. I didn't expect it to, but it kind of made sense because you're literally doing something that you can't do in real life, which is draw in 3D space and map it and see it from all angles and render it, unless it's like a sculpture or something. But it's a different practice, to say the least. So we'll draw the cube first, and I don't tell participants how to do this. I kind of let them figure it out on their own. But this is what I found, to be by far the easiest way to make a cube is using the WASD movement and then jumping at the corners, if I could press the right keys. And as you can see here, it's still not the best cube. It's more of a rectangle, or a rectangle shape, to say the least. But it doesn't have to be perfect. If I wanted that to be perfect, it would take participants way too long, I realized, which was it can mess up your data, and it can do a lot of other things too. It was a lot of fun to code this level as well, just for, a lot of learning's sake. It took a lot of videos to watch. It took a lot of understanding in Unity to actually get the stuff down. But it was really cool to see all this stuff kind of get transferred to real life. And, you can see pretty cool shapes with cool colors getting drawn and rendered in 3D space, which I thought is a really cool program, and I've never built anything like that. Now we're going to do the sphere, which I think is really cool and really pretty. And basically what I'm doing here is just moving my mouse around, just in a circle, because the way I coded it, and I knew this but my participants didn't, is that the drawing line is rendered about like 5 meters or so from the player. And so when you're doing this, if you think about it, if you just hold it and don't move, you can draw a sphere pretty easily, as shown by that, which is kind of cool. It's hardest to do with mouse, unfortunately. You can make a lot prettier ones with the gamepad and the trackball, but that was kind of cool. All right, level 3 is numbers, and this kind of showed a very clear discrepancy between how you could spatially map things out and what kind of skills it took. In other experiments, like the maneuvering experiment and the shooting experiment, I found that gamepad users had a lot easier experience with it, because I think it's just an easier way to transfer your previous knowledge and those learned skills to a similar setting. So if you played video games before, it seemed that my participants did a lot better. If I were to conduct this experiment again, that was one thing I think I would consider, is the previous history of all my participants, because I would just want that to be varied, because I think it could have impacted my data a bit, and there could have been some bias there. Besides that, what I was saying is there's fine motor skills I would say attached with drawing, and you have to have like precision and map these things you would do in a 2D space to a 3D setting, which is not as easily done, I would say, with the gamepad or the trackball. That was more easily transferred in those other experiments, and I think that's why we got more significant data in this because of that, uh, brain capacity in the areas affected that are necessary to transfer here. All right, so numbers 1 through 12. 1, 2, they're not the prettiest, but we're just doing this for time's sake. 4, that's bad though. 4, 5. Takes a while, a little repetitive, but I think it's still kind of cool. Imagine it like a clock. And while I was doing all this stuff as well, I took a lot of observational data on paper. I wasn't necessarily recording them like I am this experiment right now. However, for all my participants, I took in data such as, line legibility, the shape of their objects, whether or not it was actually a good space circle. Like mine wasn't perfect right there. Whether or not their stuff was actually readable and or whether or not they just skipped on to the next level, their actual frustration that they experienced. It was a lot of stuff to consider, and while I don't necessarily think that's going to give us, some numerical factor saying yes or this is or is not significant, I do think it's a good, inclination as to how these devices impact users' performance within these environments. And that was a big thing I wanted to study, is I wanted to compare how all of my interaction techniques were impacted using different input devices. And I think it really did show in some levels, and I think that sets up kind of a promising landscape for future research in this, and a reason to explore it, because the input devices you use does actually impact your performance, and that matters. All right, so let's go see our data. 3D drawing experiment. Clicks, undos, and time. Level 1. I had 1061. These are kind of offset. This is weird. Level 2, 1213 or 131, and all that stuff. So we're going to quit out of here, and I'm going to show you guys the next one. So give me 1 second. Okay, so this is the last experiment, the 3D maneuvering experiment, and I thought this one was a lot of fun to code as well. And I'll show you guys some of the code for this level after this as well, just to give you a general gist of what I did for implementation in all my levels. So how to use this, a basic explanation of it is, okay, the goal is to locate and reach the nuclear generator, shown below in that image, as fast as possible without touching the obstacles. If you're using a mouse or trackball, follow those controls. If you're using a gamepad, which we are in this case, south button to jump, which is A or X on the PS4, and then east button to quit, which is circle, right stick to look, left stick to move. So let's get this started. Alright, and this one was a lot of fun to implement, more just for the assets that I imported, as well as just the creation that had to go into it. I imported this entire scene, I guess you could say, or the structure, but I maneuvered a lot of these objects myself, including some of the blocks and beams and stuff like that. And then all of these barrels, they were just individual blue and yellow barrels that I imported, and then I made configurations like this and made prefabs for them and scattered them across the room, as well as gave them collision detection. So if I touch them like that, I hit an obstacle. It's a 7-second timer. And then we'll be restarted right back to the beginning, right here. So it was pretty interesting to see how participants did in this. This was definitely the one which I thought previous knowledge would have transferred, and it definitely showed. A lot of my participants who had previously played video games did a lot better in this, especially with the gamepad, whereas participants that don't play video games and have either experience with only a mouse or just using a mouse pad on their laptop, they really struggled with this. And I didn't expect that, and that's where a lot of the time went into in my experiments, was specifically in this scenario, which it just took participants wildly long. Another thing which I would like to mention here, besides it was kind of a limitation to my project overall, besides just the limited amount of participants that I was able to acquire, was a level design flaw, which was an oversight on my part for this level. As you can see right here, pretty cool. There's zero gravity applied to all of these objects. However, in order to get that randomization and that kind of flow within the objects, which was a ton of fun to code, by the way, I had to kind of not limit, but I'm trying to think of the right word. Loosen my reins on, the spaces that those objects could move, specifically the barrels. So as you can see here, a problem to this experiment is sometimes these barrels get into the room, or they just put themselves in a way that, the player couldn't actually complete the experiment within the fluidity of time that I would have liked. So using in some of the scenarios, I think it only happened once or twice, that actually mattered. But some of the participants weren't able to do it in the time that I think statistically would have shown significant data. So that was kind of an unfortunate thing, and it was an oversight on my part because it never really happened to me when I was developing this. But I do think it kind of limited the data for this scenario and kind of been a confounding variable, if you understand that. How people did best in this game, or for this scenario, I think was with the gamepad and the mouse. The trackball overall seemed to just be kind of foreign to a lot of people, and I can see why. It's a weird thing to use. I actually bought it just specifically for this project, and I actually kind of like it now, which is pretty. I guess interesting, just a side note to say. It's just very unique, and I think you can get stuff done very quickly, and you don't need a mouse pad, and it's configurable, and I like that. So that was another interesting aspect of the experiment that I just want to discuss. So I'm not going to finish it here just for time's sake, but I am going to show you guys real quick all the code and other stuff like that. So give me 1 second, and I'll be right back. Okay, I'm back, and this is some of the code I did specifically for the 3D drawing experiment, and I implemented some similar ideas throughout each of my scenarios. Specifically, like this level UI. I have level UI in each one, as you guys saw, like the starting screen, and then specifically for my drawing experiment, I have the instructions, or in the maneuvering scenario, if you got hit by an object, you see the fail screen, or if you made it to the nuclear generator, you would see that progression screen. So I implemented a lot of similar things on all these, and used a similar idea for all of them. And as you can see here, display UI, if the level started and stuff like that, what level is it, and we'll display all that. You have a wait routine here that says, okay, wait 7 seconds and display the levels in between. If we're started, don't wait, but just set the screen active, all that stuff. And then and each one as well had this set results function right here, which just writes the results to a log file and gives it like the time that it was written, just for a quick namesake to make them unique, and all that fun stuff. And it's just a CSV file, which I then process later to do all my statistics on and send them to an Excel file. Right here is a player input controls, and this is what I had to do for the new Unity input system, which was kind of a pain in the ass just to learn that entire thing, because they don't really configure very well with the old input system, which I needed to use for the mouse and stuff like that. So it was a big learning process, but you figure it out and you go from there. So this is an auto-generated file that they do using Unity, but I wish I would have learned that earlier, because I tried to write some of this myself. Learn that, and this is basically all the configurations for, as you can see here, jump, draw, look, walk, all that stuff, and you just map it to a button on the gamepad, which is kind of generalized, because I did like south button in this, so if I were to use an Xbox controller, it would have worked as well. This one was also a script that I use in all of them, and I didn't really change much of these. I imported some of this from or I didn't import, I used some code from a YouTuber that I was watching, as he just posted on his stuff, and I'll link his stuff in my GitHub, or my page that I used to post all this stuff, and show that there. But some of this was his code, some of it was mine that I just used to make with all mine, like line drawer and all that stuff. I would need to lock the cursor, and that was a big thing to learn, and I wanted some different smooth settings and just movement settings for my camera. So that took a bit to change, but I learned it as well, and that was fun. The line draw here, I basically took a lot of inspiration from a video, but I wrote it myself. So it was pretty fun to do this one, and it was very interesting and cool to do. It was a lot of ray tracing and vectors in 3D space, and just tracking movement of the cursor, which is pretty cool. And then you have the proceed to the next level here, which adds the data and gets all the stats, and then calls the UI, and it also destroys all the lines, which is another fun thing. The player here I used synonymously within every script, just so you had movement and jump and all that fun stuff, and you could change the speed and the rise and the physics on them if you wanted to, as well as if you're using a gamepad right here. This is how you check for it. The last thing I wanted to show you guys was just my log data that this is pretty similar in all of them, just different variables measured for performance. So this participant took 23 seconds in this one. Clearly it was just kind of a run through for me. Let me find a better file real quick. So this participant took 180 seconds overall. As you can see here, this last line isn't correct for some reason. It took 4 clicks, 1 undo, and 48 seconds for level 1, and then 2, level 3, and then this would be the total level or line, but that's not correct for some reason, so I need to check that. But yeah, that's kind of my general project overview. I learned some really cool things throughout this. I think I became a very better Unity developer. I think I learned a lot of stuff just about statistical analysis and experiment design, which was very cool. And I'm not going to lie, this was one of the hardest projects I've ever done in my life, if not and also one of the hardest classes I've ever taken. But, it meant a lot, and I'm really proud of my work, and I'm happy to put this on my resume. So, thanks for everybody's time. I hope you guys liked it, and peace.